Hello everyone, good day, and this is Teacher Justina, and welcome back to my YouTube channel. If you are new, then do not forget to subscribe, like, share, and to comment below for more video updates. Our video for today is all about the solution of a system of nonlinear equations by elimination method. So let us explore. Find the solution of the system using elimination method. Okay, so far our given system is x squared plus y is equal to 2 and negative x squared plus 3y is equal to 2. First, we will check as to what variable have opposite signs. So far, the x squared term has opposite signs. Thus, we will be eliminating the value of we will be eliminating the variable x. So for this, since they have opposite signs, we will be adding them vertically. So if we will be adding them vertically, so x squared positive plus negative x squared will give us a 0, and then y plus 3y will give us a 4, while 2 plus 2 is equal to 4. So since we will be getting the value of y, we will divide both by 4, and for that y is equal to 1. So if y is equal to 1, then what will be our value of x? So getting the value of x, we will be using any of the two equations will do, but getting the value of x, we will just use the equation A. And using equation A, we will be substituting the value of y into 1. So our equation A is described by x squared plus y is equal to 2. So x squared plus, since our y is equal to 1, then we were able to get the value of x in this way. So x squared is equal to 2 minus 1. So 2 minus 1 is equal to 1. And since we will be getting the value of x, but there is an exponent of 2, so we will be extracting the square root both sides. So square root of x squared is equal to, and then remember, if we will be using extracting square root, we used to have the double sign plus and minus, and then square root of 1. So for this, we have two values of x, which is 1 and negative 1. Why we have two values of x? Because our x has an exponent of 2. So there will be two values of x. So in this way, we can now conclude that our solution set will be using the first x as 1 and paired by our y. And then the second solution, this is our negative x, the second x. Solution set will be negative 1 from this, and the 1 still coming from the y. And then how do we know if our solutions 1, 1 and negative 1, 1 are correct? So let us do the checking. Again, the first one there is 1, 1 and negative 1, 1 as our solution. So we will substitute to the first. X squared plus y is equal to 2. So our x is, so we will be using the first. So 1 square plus 1 is equal to 2, and 1 plus 1 is equal to 2. So far, the 1 and 1 as one of our solution sets will satisfy to the first equation. Let us now try check the second equation, negative x squared plus 3y is equal to 2. If this 1, 1 still satisfy, so negative and then 1 square plus 3 times 1 is it equal to 2. So negative, that is already a 1 plus 3, and so far negative 1 plus 3 is equal to 2. Now we will not conclude that the two sets will be solutions to the system, not unless the two sets of solution will satisfy. So let us try the negative 1, 1, and then x squared plus y is equal to 2, and then negative 1 square plus 1 is equal to 2, and that will positive 1, and thus 1 plus 1 is equal to 2. Using the negative 1, 1 to the second equation, negative x squared plus 3y is equal to 2. So negative, and that will be negative 1 squared plus 3 times 1 is equal to 2. And this is negative 1 squared will gives us a positive 1 plus 3 is equal to 2. So negative 1 plus 3 is equal to 2. So it's uh, it is proven already that the 1, 1 and the negative 1 are the solutions to our system. Next example, we have x squared plus y squared is equal to 36, and the second is x plus 11 squared plus 2y squared is equal to 25. And then so far, this is the conics are made up of, or the system is made up of a circle. This one is an equation of a circle, and this next is an example of an ellipse. So how do we find the solution of this system using elimination method? Okay, so far, if we are going to isolate or eliminate the x, we will find it difficult because the second equation is made up of a binomial, while the first one is only a monomial term. If we want to eliminate the y, then it's possible because this is only made up of one term. But as you can see that our numerical coefficient are different. So this is a 2 and this is understood 1. And then at the same time, we will try also consider if they are of opposite signs, but they are not. So if we want to eliminate the y term or the y variable, we have to see to it that they are exactly opposite signs at the same time they are of the same constant. So if we will be making adjustments, then we will be adjusting the equation 1. So since this is a 2, we will be multiplying a 2 to all terms. At the same time, we will be adjusting this one. We will be adjusting this into negative. So how do we find out our multiplier now to all terms? We are going to multiply in negative 2. So our new equation now for for the first equation, we have to distribute. We have negative 2x squared minus 2y squared, and then is equal to, this is also multiplied by negative 2, so this is negative 72. So the next there is, we are going to expand this. So we have squaring the first term plus twice the product of 11x is 22x. And then squaring 11, we have 121. And then we're writing that 2y squared is equal to 25. So the next thing is we try check if we want to eliminate the y, are they of different signs? Yes. Are they of the are they yes? Are they of the same constant? Yes. So therefore we can now apply the vertical addition. So the negative 2x squared and the x squared will gives us negative x squared, and then there's no similar term of the 22x, so we are going to bring down, and then followed by the constant 121, and this time the negative 2y squared and the positive 2y squared, if added, it will give us a 0. So therefore the next is we are going to add negative 72 and 25, and this will gives us negative 47. So to further simplify, we have x squared plus 22x plus 121 plus 47 equals 0. Okay, so we are going to add all the constants, and this will gives us a sum of 168. And the next thing is we are to look for the factors, but it is already it will be okay, it will be good if we are going to find the factors in such a way that our quadratic term, this one, is always positive. And since it is not positive, thus we are going to have this negative outside. So we have already x squared. Originally it's positive 22, so it will be negative 22, and that will be positive original. So what should be the term inside the parentheses will be negative. So let us now factor this out. We have the factors of 168 that will give us a sum of negative 22 or negative 68, and I'm sorry, it's not negative 68 but it's 28, and it will be a 6 because 6 times negative 28 will gives us negative 168. At the same time added will gives us negative 22. So therefore, we have x minus 28 is equal to 0, and the other one will be negative 6. Okay, so to further simplify getting the values of x, we have negative x plus 28 equals 0, and this will be negative x equals negative 28, or the value of our x, first x is 28, and then the second value will be negative 6. So our x of 2 is negative 6. Okay, and at the same time, to what value is being used as our solution to the system as the x coordinate? So we remember that it is being noted in here that the function values that are closest to 0 correspond to x values that best approximate the zeros of the function. So therefore, we will be using the value of x, which is negative 6, because negative 6 is closest to 0 compared to 28. Okay, now since x is equal to negative 6, we will be looking for the value of our y. Okay, so looking for the value of y, as we know that any of the equation, would you like to prefer A or B, you will come up with the same value of y. So let us just use letter A or equation A, which is x squared plus y squared is equal to 36. And for that, we are going to substitute negative 6. Okay, and therefore, y squared is equal to 36, and that negative 6 when squared will be positive 36, and then transpose it. Thus, y squared is equal to 0, and getting the value of y, okay, of course, the square root of 0 is 0. So, this time, our solution will be negative 6, and our y is 0. So, the solution to the system is negative 6, 0. And how to verify if that negative 6, 0? So another way of checking is to try a graph, show the graph of the two, or showing the graph of the system as to find out what is this negative 6, 0 to the graph. Okay, so we have, so showing the graph at negative 6, 0, at this particular point, the graph intersecting each other. So that intersection is said to be the solution to the system. So again, this is negative 6, 0. And then as you remember that the other value of uh, y is negative 28, I think, or positive 28. So the closest to 0 will be used as our coordinate, either x or the y coordinate in our solution. So far, negative 6, 0 is the solution to the system. Okay, last example. So we have to uh, find the solution of the system. X plus 7 squared plus y squared is equal to 8, which is an equation of a circle. And then the second is 3 times x plus 7 squared plus 2 times y plus 3 squared is equal to 14. This is an equation of an ellipse. So how do we get their solution? Okay, so far, deciding as to what variable is to be eliminated, so far in the given system, the x variable is to be eliminated. So if x variable is to be eliminated, so we will make some adjustments in equation A. So adjusting them in such a way that we will be having a constant 3. Okay, so We'll be multiplying is 3. Okay, so are we sure na if we are going to use 3 as our multiplier, can we eliminate the x? Okay, we are going to also consider that they should be having opposite signs. So we will have a negative 3 as our multiplier to equation A. In this manner, we have now our new equation A. So that negative 3 will be multiplied to the given terms inside, and then negative 3 times positive y squared will be negative 3y squared, which is negative 24, because negative 3 is times 8 is negative 24. So we're writing the second equation. So we have uh, plus the 2, but the y plus 3 to the power of 2 will be expanded. So that will be 6y plus 9, okay, is equal to positive 14. So since we were able to adjust the x into different signs at the same time, same constant, we can now apply vertical addition. So in this way, we can now cancel or isolate the x. So the remaining terms will be added. So the negative 3y squared will be brought down, and then the 2 will be distributed. So 2y squared plus 12y plus 18 is equal to negative 24 plus, okay, negative 24 plus positive 14, we have negative 10. Okay, so together, uh, gathering similar terms, so far they are similar, thus it will gives us negative y squared and then plus 12y, okay, and then positive 18 plus the 10 will be, the negative 10 will be transposed. So this will be having overall positive 28 as our constant. So this time, we will be finding the factors of the remaining negative y squared plus 12y plus 28. So that will be equated to 0. And so far, to factor out trinomial, it is convenient to factor them out as to consider the quadratic term to be positive. So the y squared, so, and that is positive 12y, so that will be negative 12y. Okay, again, the given, we have y squared plus 12y plus 28. So adjusting them to positive quadratic term, so that will be positive 12y, we have negative 12y, and this will become negative 28, because negative times negative, positive 28, so is equal to 0. So this time, we can now factor them out. The factors of negative 28 that will gives us a negative 12 as a sum, we have y, negative 14, and y plus 2. Okay, why? Because negative 14 times positive 2 will be negative 28, and then negative 14 plus 2 will gives us negative 12. So in this manner, we are going to equate them to 0, and then the y plus 2 also equated to 0. Okay, so this will be negative y plus 14 is equal to 0, and this will be y is equal to negative 2. Thus negative y is equal to negative 14. Thus y equals positive 14. And the other y is, or the second y, this is our first y, is negative 2. And then as we know that it is being mentioned that the value of the function which is closest to 0 will be the approximate zeros of the function. So we will be using y value which is negative 2. So the values of our y are y is equal to 14, and the other one is y equals negative 2. So the closest to 0 is negative 2. So we are now to find the value of our x. So let us just use the equation A, because this is easier compared to equation B. So x plus 7 squared plus our y, which is negative 2 squared, is equal to 8. So this is referring to our equation A. And for that, we have x plus 7 squared, okay, plus negative 2 squared will be 4 is equal to 8. And to further simplify, we have 8 minus 4. So x plus 7 squared is equal to 4. And to get the value of our x, we need to extract the square root, both sides. Okay, so getting the square root of x plus 7 squared will be this, the exponent 2 will be isolated, as well as the radical sign. So the radicand x plus 7 is equal to the square root of 4 is positive negative 2. So we have now negative 7 transpose and then positive 2 as our x sub 1. So our x sub 1 is negative 5, and our x sub 2 will be negative 7 minus 2. So our second x will be negative 9. Okay, so therefore, we are going to have the solution, so that there are two solutions we have. The first solution is negative 5, negative 2, and the second solution will have negative 9 and negative 2. So this is the solution to the system. So if this is the solution to the system, again, so verifying them if this is really the point of the intersection of the two equations made up a circle of an ellipse. So far as you can see, our solution is negative 9 here and negative 2. So this is negative 9 and negative 2. And the other one is negative 5. This one. This is negative 5. So again, this is negative 9 and this is negative 2. So therefore, it's correct. So if you will try a look back, y is equal to 14. Y positive 14. So is there such a possibility that at y equals 14, the two graphs will intersect each other at a particular value of x? So therefore, guys, I hope you've learned something from this video today, which is all about finding the system of nonlinear equation by elimination method. So I hope if this video is useful to you, I hope you will not forget to subscribe to my channel, and don't forget to like, share, and do comment below. This has been Teacher Justina, and thank you for watching.